Hi class, let's take a look at problem G. Now we have to be careful on the exponent here. Remember that technically every single value gets raised to the second power. So let me just rewrite the expression, and the exponent is only within the values of the parentheses. So in this case, we still have the 5 n to the 4 on the outside, then technically the -1 squared times the 3 squared, and then the n to the 3 times 2. So this is supposed to be a 3. Okay, and then let me simplify that. -1 to the second, which is going to be just a +1. So in the next step, it cancels out, and I'm also going to put the n's together. So this will be now let me put the 3 to the second times the 5 first. I'm putting the constants first, and then the n to the 4th times the n to the 6th. And then at this point, we can combine the n's. Remember that the exponent just get added. So we're going to end up with a 3 to the second times 5 times n to the 10th. Now, this is a possible answer in case they want it in prime factor form. Most likely, they're going to want us to expand. So if they do want us to expand, then we're looking at, 9 times 5 times n to the 10th, or 45 n to the 10th. And that's it for this problem. Let me take another look. But the exponent just makes that a 6, combining it with a 4 n to the 10th. And then on the constants, we just have a 5 and technically a 9. That end up being multiplying. That's it for this problem. Let's move on to the next one. Now, for this particular one, we could use cancellation, but let me show you the formula that we're going to be using. And going back to the formulas, this is the formula, which you're pretty much going to be obtaining the exponent on the top and subtract the bottom. So let me actually do the cancellation so you see how that formula applies. In this case, this would be equivalent to x times x times x over x times x. And you can see here that these cancel, those cancel, and we're simply left with a x by itself. Now, if we were to apply the formula, and let me just do the formula on the side. What the formula says is, if you have the bases to be the same, in this case, you have an x to the 3rd divided by x to the 2nd. Well, in this case, this will be x to the 3 minus 2, which is going to be x to the 1st power, which you end up with a regular x. So this is just another way of approaching the problem. In general, the formula, it's easier to evaluate. But the cancellation is also fine. Let's move on to the next one. And then I'll apply the formula. In this case, I'm just going to illustrate the formula in one step. So this is equal to x to the 50 minus 4, or x to the 46. And that's it. I'm just showing one step to show that, the formula was applied. That's it for I. Let's move on to J. Now, in J, we're going to be using the following formula. And this is the formula. Let me illustrate the formulas back here. Whoops, I went past it. And this is the formula that any base except 0 raised to the 0 power, it's automatically 1. There's an explanation at the end of in the applications where we cover why this is true. For the moment, any value raised to the 0 automatically will be 1. So for problem J, this one will automatically be 1. And I'll just put the formula a to the 0 is equal to 1. That's it for this one. Let's move on to K. And in problem K, there is no exponents on the outside. So let me just remove the exponent. So this will be x times y squared times x to the 5th times a y. And then we're going to be combining the x's and the y's. So as we do this step, we're going to be multiplying x times x to the 5th times y squared and y, or x to the 6th times y to the 3rd power. Oops. And that's it for this one. Let me give it another check. 5 and 1 is going to be 6, and then 2 and 1 would be 3. That's it for this one. Let's do one more, and then I'll put the rest of them on a different video. Now, on this particular one, you could just start doing the cancellation of the x's and the y's, and we technically are left with a 2 divided by -1 or a -2. So this one, it was a lot easier to carry out the cancellation. That's it for these set of problems. I'll put the rest of the problems on a different video.